All right, guys, before we get started, are there any questions over the homework? Questions over any of the homework assignments? All right. If there's no questions over the homework, we're going to go on and get started with today's lesson. What we're looking at today is exploring more properties of parabolas, these quadratic equations. And the first one we're looking at is in the form of vertex form. We've seen this form, we've worked with this form already. This is our a times x minus h squared plus k. Now the reason we call this vertex form is because using this form here, just taking the values of h and k, we can immediately find the vertex. So they call it vertex form. Now we do have to be a little bit careful because our h value inside the parentheses is going to look a little different. Because if it's x plus 3 inside the parentheses, the value of h is not positive 3, it is negative 3. If it's x minus 3 inside the parentheses, h is positive 3. The k value is exactly what it looks like. So that's one of the things we're going to find from this here. The other is the axis of symmetry. And for this here, the axis of symmetry is x is equal to h. So the axis of symmetry will always cut through the vertex. It will go through the vertex for any and all quadratics. Now we've used this to plot the transformations, but we can find these 2 points from the given equation. So let's look at this and see how this works. So we're given this equation here. F of x is equal to negative 2 times x plus 3 squared plus 4. Now the general form for this here, f of x is equal to a times x minus h squared plus k. And we want to find the vertex, which is the point h comma k. And the axis, axis of symmetry, which is our x is equal to h. So once we find the values of h and k, we will have the vertex and the axis of symmetry. So looking at this here, h and k. Well, k is the nice one because k is whatever is being added or subtracted to the outside. Since we're adding 4, the value of k is positive 4. If we were subtracting 4, the value of k would be negative 4. No questions on this so far. Now we need to find the value of h. H is coming from inside. And h would be 3, but it would be what? Negative 3. Since it's plus 3 inside, our value of h is actually negative 3. Because the only way we can go from x minus h to x plus 3 is if the value of h is negative. Questions on how we found the value of h and k? So, our vertex h comma k. So since h is negative 3, we'd have negative 3 comma 4. That is the vertex. Our axis of symmetry, x is equal to h. So here would be x is equal to negative 3. Questions on that there? Now, if we looked at it graphically, we looked at this, and this is going to be the only one that we look at the graph for. Negative 3, 4, our vertex would be this point here. This would be the vertex. And our axis of symmetry is going to be the equation that goes through this here. Would be this line. A little bit different color. So this here is our vertex, and this is our axis of symmetry. And the reason these are helpful is it does help us graph this a little bit easier. Because for us to graph a quadratic, we need 5 points. When we were graphing the equation of a line, we only needed 2. Now, the nice thing with the axis of symmetry is that it's going to mirror from the right side to the left. So when we go about getting our 5 points, our x and y values, 2, 3, 4, 5. Our center point that we're going to use is going to be the vertex, -3, 4. Then we get 2 points to either side. So -2, 1, -4, 5 are going to be our x values. And to find the corresponding y values, well, we're just going to take the equation that we were given to start with, which is our y equals -2 x plus 3 squared plus 4, and plug in the x value. So we'll do -2. Y is equal to -2 times -2 plus 3 squared plus 4. And we could have done this with -4 or -2. We just had to pick one. Now, since everything to the right of the y equals, all of this is just a number, we can get the calculator and put -2 parentheses -2 plus 3 squared plus 4 and get the value. So it tells us when x is -2, y is 2. We can do this again, but instead of using -2, this time we can use -1 and do it again. -2 parentheses -1 plus 3 squared plus 4 is -4. So all we've done so far is just get points to plot on our graph. So we'd have -2, 2, -1, -4. And what's interesting, especially with this axis of symmetry, is that the y values will mirror to the other side. So if we go one distance to the right, its y value will be the same as one distance to the left of the vertex, 2 and 2. So that tells us that these here are our points, and it gives us the graph of the parabola. Now, part of the reason I don't put as big an emphasis on this is because we can take the graphing calculator, and the first thing we'll do to graph is hit y equals. We'll hit the y equals button and type it in. So we can say -2 parentheses x plus 3 close parentheses squared plus 4, and then tell it to graph. And this here looks pretty much like the exact same equation we had from graphing. Now, second, anytime you hit the second button, all of the blue that is written above each button will work. So if we go second graph, second table, we can look at this here. And the vertex that we found, -3, 4, is one of the points. If we go one from either side, -2, 2, -4, 2, exactly like we had. Or -1, -4, -5, -4. It gives us all those points. We don't have to calculate each one individually. It will give us all of them that we want. So there's not a whole lot of reason, especially with the graphing calculator, to graph it, because the calculator will give us everything else we would need. Questions on any of this here? Okay. So that's the only one we're actually going to need to graph. That's the only one we're going to be graphing today. The rest, we're just going to find the vertex and the axis of symmetry. Again, our vertex is the point H, comma, K. The axis of symmetry is given to us by the equation x is equal to h. Questions on this here so far? Now we just need to find the values of h and k. In the general form is our a times x minus h squared plus k. So we get h and k from the equation. K is a little bit nicer than h. What is our value of k? -2. So that means down here in the vertex, the y value of the vertex, our k value is -2. H would indeed be -4. Because we have x plus 4, so the h value has to be -4. So our vertex is the point -4, 2. Axis of symmetry, x equals h. So here x equals -4. And that's it. Questions on this here? We ready for the next one? Yes. Yes. Because once we find the values of h and k, we'll have the vertex and axis of symmetry. Let's do h first this time. So it's matching up to our x plus 1, our plus 1. So the value of h would be -1. Because when it comes out of those parentheses, we do have to change the sign. Now the question is, what's the value of k? It would indeed be 0. Plus 0. We don't write plus 0. It's just understood to be 0. Questions on how we got h and k for this here? So that means our vertex is the point -1, 0. Which means our axis of symmetry is x is equal to -1. That's it. Questions on this here? That also means if we just have x squared, we don't have any parentheses. The value of h is 0. Also, if you do want to use the shorthand for axis of symmetry, I will let you use A of S, axis of symmetry. But you do have to put x equals for axis of symmetry. Because all the ones we've looked at so far have opened up or down. So the axis of symmetry would be x equals h. We will come across some in this chapter where they do open to the left or to the right. So the axis of symmetry would not be x equals. It would actually be y equals. So we do have two separate axis of symmetries. So for us here, what's the value of h for this equation? +2, because it's coming from our x minus 2. So this time it would go from negative to positive. Our value of k, which would be our +5. Now our vertex is the point h comma k, so it would be 2, 5. The axis of symmetry would be x is equal to 2. And that is it. Questions over any of this here? We feel good about these so far. All right. Well, the second form we're going to look at is standard form. Now, this here is just a way that we would go from one to the other. It's not essential for you to understand this concept here. The main thing is that standard form comes in the form of ax squared plus bx plus c. Now, if the value of a is greater than 0, if the value of a is positive, it's going to open up. If the value of a is negative, it's going to open down as our reflection across the x-axis. If a is positive, it opens up. If a is negative, it opens down. If the graph is narrow when the absolute value of a is greater than 1. Just a is greater than 1. It's a vertical stretch. If the absolute value of a is less than 1, or essentially saying if it's between 0 and 1, it's a vertical shrink. We've talked about these already. Now here it states that the vertex is the point negative b over 2a, comma f of negative b over 2a. And the axis of symmetry is the equation x is equal to negative b over 2a. Now, even though this does look a little bit different, the x value of the vertex and the value that we plug in for our axis of symmetry are still going to be the same value. It just looks a little bit different in how we get it. And the only other thing of interest is that the y-intercept is c, is whatever that c value is. Because the point for the y-intercept is 0, comma, a number, because the x value is always 0. And if we plug 0 in for x, ax squared and bx would become 0. We're multiplying by 0. Doesn't matter what a and b are, which would only leave us with c. C is always going to be the y-intercept. So, we're given this here. First thing I'm going to do is write the general form of a quadratic, our standard form for a quadratic equation underneath it. Now, one thing I do want to point out, a, b, and c, the value for a, b, and c will never have a variable for this here, unless we're talking about general form or we're trying to plug some stuff in. Because when we're relating this back to a quadratic equation here, 3x squared minus 6x plus 1, a, b, and c will not have x as a part of their value. Because if we look at this here, a is the number in front of x squared, ax squared. Well, what's the number in front of x squared? 3. So a is 3. B is the number in front of x, which is be 6, but it would actually be negative 6. Yeah, because it would be negative 6, and the reason it is because in the general form it's plus bx. So the only way we can go from positive bx to negative 6x is if b is negative. And lastly, c would be the number without a variable, which is positive 1. Questions on how we found a, b, c? Okay. Now we still want to find the vertex and the axis of symmetry. Now the vertex for us is a little bit different. It's our negative b over 2a, comma f of negative b over 2a. Axis of symmetry, x is equal to negative b over 2a. So I'd say the first thing we really need to find is what negative b over 2a is. So negative b over 2a is equal to, well, let's plug in the value of b. Well, we found b to be negative 6. So the top of this would be negative 6. The bottom is 2 times a, so it would be 2 times 3. So we'd have negative 6 over 2 times 3. Now looking at this here, is anything in that fraction a variable? No, it's all numbers and signs. So is there any reason we can't just type that whole thing into the calculator as it is? No, we can type that in. You can type in negative 6 over 2 times 3, hit enter. It will give you the answer. If we did this by hand, negative 6 is positive 6. 2 times 3 is 6. And 6 divided by 6 is 1. So the x value of the vertex is 1. Well, that also gave us something else, the axis of symmetry. Because x equals negative b over 2a. Well, negative b over 2a is 1. So the axis of symmetry is x equals 1. We have 2/3 of our answer. Now the only thing that remains is finding f of negative b over 2a. Well, negative b over 2a is what? 1. So it's asking us to find f of 1. You all remember doing this, function notation, f of 1. All that's saying is, what is the value of this expression when x is 1? F of negative b over 2a is, take whatever negative b over 2a is and plug it back into the equation. So we're just plugging 1 back in for x. So we're taking 3 times 1 squared minus 6 times 1 plus 1. Well, again, at this point, there are no variables. Type the whole thing in the calculator. Let it do it for you. If we did this by hand, 1 squared is 1. Negative 6 times 1 is negative 6 plus 1. 3 times 1 is 3. Negative 6 plus 1 is negative 5. And 3 minus 5 is negative 2. So the vertex would be the point 1, negative 2. And the axis of symmetry is x is equal to 1. Questions on this here? Y equals 3x squared minus 6x plus 1. Graph. We do get this here, second graph. One negative 2 was our vertex, yes? We go one spot up or down. The y values are the same. We go 2. It's the same. So that is indeed the vertex. So we do have the correct spot. Huh? Question? Yeah. So that kind of is a way to confirm that it is the vertex. Because we should have that parallelism across either side. So the first thing we can do that might make this a little bit easier is to find the values of a, b, c. And we can compare it back to our ax squared plus bx plus c. Well, here, a is going to be the number in front of x squared, which in this case is 1. The number in front of b is, or x is 2, our b is 2, and c is negative 1. vertex, axis of symmetry. So our vertex is going to be the point negative b over 2a, comma f of negative b over 2a. Axis of symmetry, x is equal to negative b over 2a. So the first thing, the main thing we need to find is negative b over 2a. Well, our b value we found was 2. The a value is 1. If I were to type this in the calculator, I would just use the 30xs, negative 2 over 2 times 1. Which is indeed negative 1, because if we did it by hand, our negative 2 would just be negative 2. 2 times 1 is 2. Negative 2 divided by 2 is negative 1. Well, that gives us half the vertex and the y-intercept. Or half the vertex and the axis of symmetry, because axis of symmetry is x is equal to negative b over 2a. So here, x is equal to negative 1. To find the y-axis, or y value of the x, or y value of the vertex, all we have to do is plug the x value back in. So we'd have negative 1 squared plus 2 times negative 1 minus 1. If we did this in a calculator, parentheses, negative 1 squared plus 2 times negative 1 minus 1 is negative 2. Because if we did this by hand, negative 1 squared is 1. 2 times negative 1 is negative 2 minus 1. 1 minus 2 is negative 1, and negative 1 minus 1 is negative 2. That'd be it. That is our vertex and axis of symmetry. Questions on this here? Do we feel like finding the vertex and axis of symmetry for standard form was a little, it seemed harder than it was? Because it seemed like it'd be a very complicated formula, especially with the negative b over 2a comma f of negative b over 2a. But once we find one, we just plug it back in. So we have this one here. Negative 2x squared minus 8x plus 1. Our value of a would be negative 2. Our value of b is negative 8, and c is positive 1. So our vertex is our negative b over 2a, comma f of negative b over 2a. As we found already, our value of b is negative 8, and a is negative 2. So we have negative 8 over 2 times negative 2. And again, at this point, we can type this all into the calculator. The calculator would do it for us. If we do this by hand, negative 8 is just 8. 2 times negative 2 is negative 4. And 8 divided by negative 4 would indeed be negative 2. So that tells us the x value of the vertex is negative 2. And our axis of symmetry is x is equal to negative 2. Because once we get that value, we're 2/3 of the way done. Now we just have to take negative 2 and plug it back into the equation. And again, we could grab the calculator We say negative 2 times negative 2 squared minus 8 times negative 2 plus, is it 1? I already lost it. Yep. And we get 9. Because if we did it by hand, it'd be negative 2 times 4 plus 16 plus 1. A little more space in that. Negative 2 times 4 would be negative 8 plus 17, which indeed would be 9. And yes, if I wanted to, we could have grabbed the calculator, put y equals negative 2x squared minus 8x plus 1 graph. Second graph, negative 2, 9 is indeed our vertex because it is that highest point and they do mirror across either side. So the graphing calculator does give us this here. The only time that this would cause, we wouldn't be able to fully do this is if the vertex was not at a nice point, whole numbers, or integers, if it was rational. But that's where we're going to stop for today. Huh? 4? Oh, this 4? Yeah, negative 2 squared would give us 4. Yes. I believe it is already posted in Google Classroom, but this is the assignment. You should already be able to do part of it, just from what we've done so far. You do not have to graph any of these. But 3 through 9, odd, we have already done those there. 15 through 18, you should be able to do just find the vertex and the axis of symmetry from the given graph. So you're just A, B, C, D for those there. 21 through 29, odd. Again, that's just what we did for the second half with standard form. 33, 33 is. Just find the error. You can do that. That is dealing with standard form. They're trying to find the value of negative b over 2a. The only ones we have not done yet are the 53, 55, and 56. Those we'll do tomorrow.